Good morning, class. And I will typically say good morning, even though it might be afternoon or evening or the middle of the night or whatever, anywhere in between. Um, First and foremost, I'd like to say that I'm hoping that you're healthy, your family is healthy, and that you're able to figure some things out in terms of staying up on the schoolwork that I know the district is asking you to do. In terms of this class, you already know that I've forwarded or posted a worksheet or quiz, you might call it, take-home quiz from section 9.1 through 9.3. So make sure that you know that if you have any questions on any of those problems, you may send me a quick email or message, and I will get back to you as soon as I can and give you some guidance on those. The hope is that through a series of these short lecture videos, reading the sections and studying these examples, and then also trying the problem sets, that you're able to leave this course with a foundation that's going to let you be successful in future courses. So today is really the first day for that. Eventually I will post all of these videos on YouTube, but I will have a link on Schoology in our Schoology course. If at any time you have trouble getting to the link and getting to YouTube to view these, make sure you let me know, because I do want to stay ahead of any troubles like that. So let's do it. The topic of today involves another way of denoting a point on a plane. So far, this is what we have. Every point on this whiteboard could be thought of as an XY coordinate. And that's pretty simple. We've been doing that since elementary school. To get to this point, you're going to move over an X value, and you're going to move up a Y value. We sometimes call these rectangular coordinates because we always move in right angles to each other when we're getting to that point. We have equations. We've solved a variety of things with these. We know there are classic curves like parabolas and so forth. But today, we're going to look at what's known as polar coordinates. And polar coordinates is nothing more than renaming that type of a point. And in order to rename it, rather than a left and right movement up and down, we're going to think of two different movements. One is a rotation, and the other one is a moving from a pole or out concentric circles. So, for example, maybe we can think of some concentric circles around a point, and this would be the point. And that point we refer to as the pole. And then we're rotating also along this positive x-axis, but we call it the polar axis. So another way to get to this point isn't so much to move x and y, but to rotate a certain degree angle, we'll call it theta, and then to move out a certain number of units. In this case, it looks like 4, but that's not even the important part. It's going to be some r value. So this point can now be named r theta. And I know even though I moved theta first, or we list r first, I kind of moved theta first. I like to rotate then move out. So one of the things that we're going to be expected to do with this new system is quite simply just plot points, or name points. This board does move a little bit, so I have to write rather carefully. So if it shakes too much, I apologize for that. For example, let's say we want to plot the point 2, 30 degrees. Well, what I would do is you can still start with the XY axis or just the pole and the polar axis. I'm going to rotate 30 degrees, and then I'm going to move out 2 units. So that would be the point 230 degrees. Now I might want to label it, and there I have a point. Here would be another possibility for an example. What if I had like -3 and then 120 degrees? Well, that negative is going to pose a little bit of an issue, but not something we can't get past. We first are going to rotate the 120 degrees. So if I start at 0, 120 puts me about here. It's like 120 degrees. And now, what I want to do is move -3. Well, if I'm rotating this, I'm basically looking this way. And so moving -3 would be going 3 units back. In terms of these concentric circles, there would be kind of 3 concentric circles. So this right here would be the point -3, 120. So the angle could be positive and negative, could be 900 if you wanted, and then the R could also be positive or negative. Positive, you move out along kind of the arm of the positive direction of the angle. And negative would be you're moving in the opposite ray, the opposite direction. So that's one of the things you're going to be asked to do, rather basic. Maybe the more important thing up to this point would be to convert. Now, we've done this throughout the year. When we started this whole trig course, we knew about degree measure for an angle, and we looked more closely at radian measure. So one of the things we had to do was convert. Well, the same thing is going to be true here. But the triangle that you look at pretty much tells you our conversions. One is that if I look at theta and r, I can come up with a couple trig relationships that help me. For example, the cosine of theta is just going to be x over r, which means r equals, let me change that, x equals r cosine theta. If same argument, we would get y to be r sine theta. This is an important set of conversion formulas. So in other words, if I would give you this 230, I could find the x and y that match up with it. Because r is 2 and the theta is 30. So for this example, the y would be 2 times sine of 30, which is a half. We get 1. So I'd move over 1 unit. And we could do the other thing with the y. The other thing you would notice is that if I just look at the x and the y and the r, x squared plus y squared, according to the Pythagorean theorem, would be r squared. Likewise, the tangent of theta would be the opposite, which is y over the x. Now this could be another set of conversion formulas, each of which can be rewritten. Here we could write it as r equals the square root of x squared plus y squared. And then here we could write that the arctangent of y over x is theta. So you can play with those as you wish. But in this case, I might give you the point, let's say 3, 4. And then you can turn it into the polar coordinates. Because if x is 3 and y is 4, r would be 5. If x is 3 and y is 4, then we could find the theta that goes with it. So naming and plotting points, one thing. Converting, rather important. Now, the other thing we can do is to work with what we could call polar equations. We could even convert them. Because again, just like we have lines in our rectangular coordinates, we have circles, we have parabolas, we have cubics, we have all these different functions that we know very well. We also have a lot of different well-known functions for polar graphs. And some of them are the same. And that's where the conversions will play a part. Let's just take a look at an example. If we happen to be expected to graph r equals 6 cosine theta, we've got some options. One option is your calculator. You'd have to put it in polar mode, and I'll help you maybe with another short video one day to help to go over that. The other option is to just make a table. And that's what I'm going to start with here. I'm just going to make a table of values. So let's do that. In other words, if I choose some theta values, what is R that goes with it? Well, if theta, let's just go with 0. That's an easy one. If I plot 0 for theta, R would have to be 6. Let's move up another nice one. Let's say I would go to pi over 4. Cosine of pi over 4 is radical 3 over 2, so this would be 3 radical 2. And we'll figure out that value in a minute. You could have your calculator, that would help. Pi over 2. Cosine of pi over 2 is 0, so we get 0. And then we could go to maybe 3 pi over 4. Cosine of 3 pi over 4 is negative, so we're going to get negative radical 3 over 2. And you can check all of these values if you'd like. And then maybe pi. Pi, we're going to be back to, I think, it's negative 1, so it's negative 6. So let's just try to plot these points. So I'm going to kind of draw the xy axis, but really know that that's my polar axis. So here we go. First point, move 0 degrees and then out 6 units. That's a point for this one. I'm going to do some of these easier ones first. Pi over 2, I'm going 0. So if I rotate pi over 2, I'm not moving at all. So I'm going to stay at the pole. Let's go to this one. I move pi, rotate pi degrees, and then now I go back 6. That means I go this way 6. Well, I'm just back here. So these 3 points, 2 of which are the same, doesn't give me a lot. Now let's go to this one. Pi over 4 is going to be that 45-degree angle. And then 3 radical 2 is probably about 4.2. So if we go out about 4 units, we're going to be about right here. Okay, that would be this point. And then if I rotate 3 pi over 4, there's 3 pi over 4, and go back about 4.2, I'm going to be right in this point. Well, to make a long story short, if we would continue to find enough points, what we would notice is that this is my first point, and I basically get a circle. Should have moved that over a little bit. So this is a circle. Now let's see how we can maybe use that in terms of a conversion, okay? So here we'll convert. What I'm going to do, because I want to make use of this, is multiply both sides by r. So I get r squared equals 6r cosine theta. Couple things you notice. This is just x squared plus y squared. What's that? That's x, 6x. So if you get x squared plus y squared equals 6x, we end up with basically a circle. So we would maybe subtract, now let's say what I want to do with that. Well, we'll just keep it like that for now, right? So we may recognize it as a circle. So what we have so far is a new way to talk about a point on the plane. And that is with using these things called polar coordinates, where there's an r and a theta. In working with polar coordinates, we should be able to plot points and name points. We should be able to convert between xy coordinates to polar and polar to xy. And you will see a few in your problem set that want you to get comfortable with trying to graph or get a better feel for some of these polar equations. Some of them, by conversion, you might recognize as what it should be. In this case, a nice simple circle. But others, you could use your calculator to find it. So maybe in a few minutes, I'll send up another video involving the calculator. Other than that, that's our first lesson. Please let me know if there are any issues or questions, and I will get back with you very, very soon. Have a good day.